Hi guys, welcome back. Today we're going to talk about cylindrical equations, and the first thing we're going to do here is look at these three pretty basic equations and just basically just talk about what they look like, the graph of the surface for this. So the first thing we're going to do here in example 6 is we're just going to look at a very basic that theta is equal to pi over 4. So we're going to, down here what we're going to do is we're going to look at the positive x-axis and we're going to go ahead and create ourselves an angle with the positive x-axis. That's going to be our theta, and this theta is going to end up being pi over 4. And so in the previous video, we can restrict our theta from 0 to 2 pi. We could literally go all the way around this axis, to go around the z-axis to make ourselves a circle. So in this particular example, we only want to know what this looks like when theta equals pi over 4. So since this is a cylindrical, we are actually going to create ourselves a three-dimensional shape here. And so what's actually going to happen is that, and I apologize for my horrible graph here, it's just actually going to create ourselves this nice little plane. And so it's going to be a plane that's going to be coming out of the z-axis, and it's going to create a theta, an angle, with the positive x-axis of pi over 4. And so that's what the graph is going to look like. Now we also want to convert this. We want to make this actually into a Cartesian equation. So what we're going to end up doing here is we're going to take the tangent and do the tangent to both sides. So I'm going to go ahead and change my color here for a second. So I'm going to go ahead and do the tangent of theta is equal to the tangent of pi over 4. Now why we can do this is because the tangent of A, if the tangent of A is equal to the tangent of B, then A and B have to be equal to each other. So basically I'm doing this because why did I choose tangent? I choose tangent because that's one of the equations that we know, right? This is one of the equations that we did on the previous page. So I know that the tangent of theta is simply going to be equal to y over x, and then the tangent of pi over 4 is going to simply be 1, and so I get the equation for this particular example that this equation is going to be x equals y. And so just really quickly, we're going to go back over here to our first page, the first video. This is why I use tangent, right? Because I have a relationship now because I want to get it into terms of x, y, and z. And so here we go. We have tangent of theta is equal to y over x. And so that's what I wanted to do for that particular example. Okay, so hopefully that makes sense. Again, not the best picture, but the idea here is it's a plane, and it is going to be out of the the z-axis, and it's going to be created by the positive x-axis right here. So we would just, as theta moves around, we would move the plane around the z-axis. Okay, so now we want to look at the function for our equals 2. So again, we want to start manipulating this problem, but let's look at the graph for it for a second. But first off, I'm actually going to do the equation for this one. So if I look at this problem here, I'm going to go ahead and square both sides. Because again, I need an equation that gives me my x and my y's. And so over here, we're going to now use this equation, right? So we know that how can we get x and y out of the radius? Well, we can square it. And so that's why we chose to do this. So I can now say that x squared plus y squared is equal to 4. Now, if we're looking at a two-dimensional shape, then we know that this is obviously going to be a circle at the center of radius 2. But if we're looking at the actual thing for this one, what we're going to do is we're actually going to create ourselves a cylinder here that the radius is actually going to end up being 2. And so it's going to be on the z-axis. And so this bottom part right here, if you would actually graph the bottom part, would actually be the circle around this with the radius of 2. And we have to incorporate the fact that z, and z can be anything. So this cylinder can be as high or low as you want it to be, right? There's no conditions right now for z. There's no restrictions for z as well. So the general shape for this is going to be a cylinder of x squared plus y squared equals 4. And the actual base itself that we see here, that's actually going to be that circle. So this is actually x squared plus y squared equals 4. And we're just going to create ourselves a cylinder. So that's basically what you would see for if you have radius is equal to some number. All right, and then the last one we're going to do here is we're going to look at r squared equals 4 minus z squared. So just like in the previous example, we actually already know, excuse me, let me erase this. We actually already know that we're going to replace r squared with x squared plus y squared. And we're going to go ahead and move the z squared over and equal to 4, okay? And so this is basically what we need to do with this problem. This is the actual equation for it. It's all in Cartesian now. We have our x, our y, and our z. Again, because we're looking at a z coordinate here, this is actually going to create ourselves a sphere. So x squared plus y squared plus z squared is actually going to be a sphere that's going to be centered at the origin, and it has a radius of 2. So I cannot draw just some dimensions on this thing right here, but it's going to end up being like a sphere looking thing, and this is my horrible thing for that, but there we go. There's a little sphere, a little texture on this, and so that's what it is. So x squared plus y squared plus z squared is always going to be a sphere, and again, we're going to have a radius of 2. So the radius of the sphere would actually be equal to 2 in this case right here. So there we go. There's our equations for this, and so we're going to move back down and do the opposite side of this. By the way, this is not the equation for this. This is just telling you that the radius is 2 here. So I don't want you guys to think that these are the exact same equations. I'm just telling you that this is a note to that sphere. So that's why they're different. Okay, so these actually are very simple to do. It says convert from Cartesian to cylindrical. And so there's not very much work when we're looking at these particular problems. So x squared minus y squared equals 4. That's probably the one that's a little bit more challenging. So what we want to do here is we want to make x into r. So remember, x, if we're looking at cylindrical coordinates, is actually going to be r cosine of theta. That's what the x value is. And we're going to square the whole thing. And we're going to do the same thing with y, right? So we're going to go ahead and do r sine theta squared, and we get to this. Now we want to simplify this down a little bit more, right? We actually did what we wanted to do. We have r's, we have thetas, and we're good now. This is in cylindrical coordinates, but we want to actually get it into, typically we want to find r or r squared. So we're going to go ahead and do a little bit more manipulation here. We're going to go ahead and square these two things here. So r squared cosine squared, and then we do minus r squared sine squared theta, and we're going to set that equal to 4. And then we're going to go ahead and undistribute this this r squared. So we're going to undistribute this, and we get some nice identity that we know inside these parentheses. And again, we're just trying to get r squared kind of by itself. So when we undistribute the r squared, we get cosine squared minus sine squared. And so hopefully everybody knows that that is the identity for the double angle for cosine, one of them actually. And so I get that r squared is times cosine of 2 theta equals 4. And then if I want r squared by itself, if I divide by cosine of 2 theta, I'm actually going to multiply. So this would be 4 divided by cosine of 2 theta, but it's actually the same thing as 4 times secant of 2 theta. And so this is going to be the equation that most likely you would see as a multiple choice question. I think that would be the idea for that. So that's kind of the ones that you have to do a little bit of manipulation to, and again, typically they like to have it where it's r squared or r is equal to something with theta in it. The rest of these are actually pretty straightforward. This one, there is no real work to it, just recognizing that x squared plus y squared is equal to r squared, and so we get that that's equal to z squared, and since z is also cylindrical and Cartesian, we're okay with z there. And so the only thing that you may want to simplify down a little bit more is that the radius will end up being what the z coordinate is in this particular example. So, and again, I'm only doing the positive root here because the radius can only be positive. And it's just like the previous one, it's very simple, straightforward here. This is just going to be r squared on the left-hand side. It's going to be 4z. And then I really don't do too much with this one. I could just do an r squared minus 4z equals 0. I could leave it alone like this. I could technically do a square root of 2 square roots of z, however I want to do this, but I'm going to be okay with it right here. So this is our final product for cylindrical, and so in the next videos we are going to start talking about spherical coordinates. So hopefully this makes sense, and I'll see you guys in the next video.